Are we living in a simulation? That is the question. It's basically like asking, are we living in a video game, or is our reality not real? One that is, say, embedded inside another reality. Uh, Elon Musk certainly seems to think so. He said that the odds that our universe exists in what he calls base reality must be something like 1 in a billion. And he just makes that claim simply based on the assumption that building, or not even assumption, he truly believes that it's possible to program our reality. He says, basically based on information theory, it is hypothetically possible to simulate uh, this reality. And so, because it's possible, not now, it's not possible now, but because he believes it's possible down the road in the future, that because it's possible, it will be done, and therefore it already has been done. Uh, which I can totally jive with. I think what the odds of us living right now in the here and now, with after hundred thousands of years, that I'm alive here today in the most technologically advanced civilization of all time. Uh, as opposed to, say, some other time period in the universe's, or not, I shouldn't say the universe, the planet Earth's, uh, 4.6 billion years or 4.4 billion years of existence. The idea that I'm here, age of the United, it seems like it's unreal. But I don't want to go into that. This is not about, like, I'm not going to be using fuzzy logic to argue why I think we live in a simulation. Uh, we're going to try to get into some actual, uh, real logical arguments here, based on, well, I know this is going to sound like a real buff, based on quantum physics. Okay, so let's start with the the hydrogen atom. This is a hydrogen atom. Okay, well, this is an artist's conception of a hydrogen atom. Uh, Now, why is it drawn with, look, why does it look like such a cloudy, ill-defined blurb? Like, it's all fuzzy, hazy, without detail. Uh, well, as I said, it is artist's consumption, or an artist's conception, but it's supposed to illustrate the all mysterious wave function. Now, do you know what the wave function is? It's actually just a mathematical construct, um, which is to say, it's not a real wave, because it's basically what is waving is is a probability that a state of matter is going to be detected in this state or the next. So the wave function, Schrodinger's equation, you can really see it as a probability density function. Uh, and so, to use this photo as an example, you can see that the areas that are more densely orange represent areas where the electron is more likely to be detected, aka collapsed. Now, the Copenhagen interpretation of quantum mechanics states that systems at the quantum level do not have definite properties prior to being observed or interacted with, and that it is observation which collapses an otherwise indefinite state of the universe into one that has to abide by classical mechanics. Uh, Quantum mechanics, therefore, cannot deduce definite properties of quantum scale matter. Rather, it's going to use a probability distribution functions known as wave functions in order to deduce the probability of various classical states of matter upon observation. So the probability that the state of matter will fall into this state or to that state once it is uh, been collapsed as a result of observation. Now, I'm not gonna. I know you're gonna say, well, what define observation? Not right now. not right now. Now that's another topic for. Well, we'll get into this. The top purpose of this video is just to discuss: do we live in a such situation? So I'm not going to get into whole theory of quantum mechanics here. So you go watch another video for that one. All right, I'm going to keep going. Anyway, so the consequences of not having definite properties, that basically means that we couldn't capture a more detailed photo of this hydrogen atom, like even if you had a camera that say had an infinitude of pixel space. Now, here's the big question. Where else do we see this phenomena? Where else do we see it? And the answer is video games. So, in a video game, we do have something called a process that's called procedural generation, and I'm going to need a couple of photos to show you this. But basically, in a video game, in order to conserve computer power and improve rendering speed, game designers use something called procedural generation, or maybe you know what? No, sorry. It's called procedural rendering. Procedural rendering, in order to create textures and details of the world. Uh, yeah. So basically, this is how that works. As a player will approach objects in the simulated world, the objects will be rendered in detail proportional to the vantage point of the player. If the player is near a tree, for example, they can view the tree bark and leaves in exquisite detail. However, the game will not have generated the bark and leaves of every tree in the simulation because the player is currently not observing those features of the simulation or video game. And rendering all, if it had to try to render all such features across an entire world, that would be a tremendous waste of computing power, because the game player is not interacting with those aspects of the world at that time. So why does it need to create all these details? So this is where procedural rendering comes in, where basically details of objects in a game will become more specific, or I guess you could say defined, as the player interacts with it. So, for instance, in this image here, you might start off with an image in a game, an object looking something like this, but then later, after procedural rendering, you could have it looking more like this. So this basically, anyway. So this is obviously very similar to the collapse of the wave function in quantum mechanics, where quantum particles, they don't take on this state or that state unless observation or interaction takes place. Other than that, it's ill-defined, or it's yeah. So basically, this shows that real reality and virtual reality can share similar conceptual designs, and we can prove all this simply by observing the hydrogen atom. Now, is this proof that we ourselves are living in a simulation? In my opinion, it's well, first off, there are some reputable scientists who sort of believe so. There's Seth Lloyd, who wrote Programming the Universe. But in my opinion, it's impossible to say. And first of all, I think to say, do we live in a video game? Do we not live in a video game? Uh, it's all some semantics. The real question you should be asking is, would the base universe, so we're not living in a simulation, would still have to abide by the laws of information theory? Now, information theory is like a bunch of rules, formulas. It's basically the Euclidean axioms of computer science, and it's applied to describe the limitations, to create for creating simulations or video games. Uh, Now, those axioms in information theory, they're pretty solid. Uh, they could, I mean, obviously they apply for, video game environments, but it's hard to imagine that they wouldn't apply in base reality. Maybe you could still apply them even if, though, you could make the argument that we're not in a simulation. But anyway, that's the whole argument that to say that base reality would not need to abide by the rules of information theory. Uh, that's basically like saying, okay, we must live in a virtual reality or a simulation because our universe does seem to abide by those rules. By quantum mechanics is just basically procedural rendering in a video game environment. Like they're the same, and yeah, and that's because whoever created our universe, obviously they're trying to save computer computer data, programming data. Like their Xbox. Like, could you imagine if the multi-worlds version of quantum mechanics were true? That every instance, the universe is breaking off into these different states, and each state is actually happening. And like, if all those other multi-universes were real, well, for one, it would violate the rule of the conservation of energy. Uh, but two, that would generate an infinitude of more data every possible second, every moment. Uh, like, it would be nuts. If our simulation were existing in someone else's Xbox, another base reality, that Xbox would explode. Uh, yeah. So anyway, that's my whole take on it. I don't really have a view. Yes, I do think we are living in a simulation. Now, is it a simulation that exists in another simulation? That I still think is up in the air. I don't think just because you can uh, find some similarities between quantum mechanics and procedural rendering, uh, that implies that reality must be embedded inside another reality. I still think the laws of information theory could still arguably apply to any base reality too. That's not, to me, there's no I mean, I can't prove that it would, or give you a good argument that it would, but I can't say, oh, obviously, just because our universe seems to, the laws of information theory seem to be followed in our universe. That doesn't obviously prove that we're a simulation embedded in another simulation. To me, it's not obvious. Some people think maybe it could be. Anyway, that's my take on it. All right, thanks, and I hope to see you again soon. Bye.